All right, so this video we're going to take a look at measures of dispersion or measures of variation. Basically we're going to talk about range and standard deviation. All right, so measures of dispersion are used to describe the spread of data items on a data set. Okay. And like I said, we'll look at range and standard deviation. We will discuss the two most common types of dispersion, range and standard deviation. The range is the difference between the highest and lowest data values in a data set. It indicates the total spread of the data. So here's your formula here for range is the highest data value minus the lowest data value. So let's go ahead and take a look at an example. It says the ages of the 4 oldest presidents at the start of their first term are shown below. Find the age range for the 4 oldest presidents. All right, so the range, well, remember that's the highest data value, which if we look through this list, that's 70, minus the lowest data value, which is 65. And so that would be 5. That's the range of the data value. Well, and I guess we could put 5 years because we're talking about age. All right. Now, let's look at standard deviation. So range is easy. That's just the largest minus the smallest. Now, the standard deviation, we have a formula here. So you notice there's two formulas here. This first formula is for a sample, standard deviation, and this second one here is for a population, standard deviation. Now, more than likely, you're going to be using the sample standard deviation, this first formula over here. And you know, you gotta know this formula. It's the standard deviation S, and let me say this: S is used to represent sample standard deviation. Sigma is used to represent population standard deviation, and you can see the difference in them. The sample is divided by n minus 1, and the population is divided by n. Now, standard deviation, there's different ways that you can see this formula written. Like for instance, the statistics book. Now this, you got to understand, this is contemporary math class. This comes out of a contemporary math book. And the statistics class I teach, the formula for standard deviation is actually this right here. The sum of x squared minus the sum of x squared over n over n minus 1. Okay, and actually there's another textbook that I've seen for standard deviation, and the formula is different than this. They basically multiply numerator and denominator by n and have an n here, nothing here, and then n times n minus 1 here. Okay, and they all give you the same answer. So the thing that you've got to understand is how to read the formula. Okay, if you can understand the formula, then it doesn't matter which formula you have. I've got another video, if you search my channel for finding standard deviation or calculating standard deviation. In that video, I use one of these other formulas instead of this one up here. Now, the reason I'm using this one up here is because that's the one the book uses for the contemporary math class. But you know, it's not difficult to do. So look, all this means is you take x minus x bar Okay, you find x minus x bar, you square them, you square each one, and then you sum them up, and then you divide it by n minus 1. Okay, now let's, instead of me sitting here trying to explain this more, let's look at the example and see what happens. So first, how about we do this? How about we write down the formula. That's the sum of x minus x bar squared over n minus 1. All right, so there's our formula. So you can see what we have here. We have x minus x bar. Now what is x? X are the data values here. So we've got to subtract each of these data values. We got to do each data value minus the mean. Okay, so the first thing we need to do is we need to find the mean of this thing. All right, so the mean is equal to, remember, that's the sum of all the x values divided by however many x values we have. So that's going to be 70 plus 69 plus 68 plus 65 divided by 1, 2, 3, 4 of them. And so the mean is 68. All right, that's the mean. Now, what I would do is I would just go through and make a table. Okay, I'd make a table. So let's do that. So let's write the data item. Let's make a table x. That'll be one column. And then let's make a x minus x bar column. And then let's make a x minus x bar squared column. And let's see what we get. So that's going to be 70, 69, 68, and 65. All right. So let me go ahead and do this. Let's move this line over some. Give us a little more room. All right. So let's go ahead and do the x minus x bar. And I guess we'll do it in a little bit different color. So we've got x, which is 70, minus x bar, which is 68, and that equals 2. That's all we're doing. We're taking each of these minus the mean. So we've got 69 minus 68 equals 1. And then we've got 68 minus 68, which equals 0. And then we've got 65 minus 68, which is negative 3. All right. And then what we do is we square each of these values here. Okay. So 2 squared is 4. 1 squared is 1, 0 squared is 0, and negative 3 squared is 9. All right. Now, what does our formula say we need? We need the sum of x minus x bar squared. So the sum of x minus x bar squared, see, that's what this means. You find this, and then you sum them up. So that is equal to 14. All right. Now, in this problem, what else do we need? We need n, don't we? See, we've got the numerator. Now we need n. Well, n is equal to 4. All right. That's n. There's n is the number of data values, 1, 2, 3, 4. All right, so now our standard deviation is S equals the square root of the sum of x minus x bar squared over n minus 1. So we've got the square root of that. And so that's going to be the square root. So this is going to be what? 14 over 4. And when you punch that into your calculator, you end up getting 2.16. And there's your standard deviation. All right. All right, now let's look at this one. So we got this example that we're fixing to do, and then one more. All right, find the standard deviation. All right, find the standard deviation. So let's make a chart just like we did a while ago. So that's x. And then we need, before we make the chart, let's find the mean first. So x bar, let me write the formula down again. So that's going to be S is equal to the square root sum x minus x bar squared over n minus 1. So let's find x bar. That's the sum of x over n. So that's 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35. All that over how many data values do we have? 1, 2, 3, 4, 5, 6, 7 divided by 7. And that ends up being 20. So there's our mean. Okay. All right. So now let's make our table. So I've got x. And that is going to be 5, 10, 15, 20, 25, 30, 35. Okay, so there's our x values. And then I need x minus x bar. Okay, so remember x bar is 20. And so, I mean, you can write 5 minus 20 is negative 15, like I did before. See, if you need to write this part of it out, this part here, that's fine. Or you can just write this out. It doesn't matter. Okay? So let's get that. Let's do 5 minus 20 is negative 15. 10 minus 20 is negative 10. 15 minus 20 is negative 5. 20 minus 20 is 0. 25 minus 20 is 5. 30 minus 20 is 10. And 35 minus 20 is 15. Okay, so that's all you do. And then you've got x minus x bar squared. So I need to go through and square each of these. So negative 15 squared is 225. 10 squared is 100. Negative 5 squared is 25. 0 squared is 0. 5 squared is 25. 10 squared is 100. And 15 squared is 225. All right. Now, come up here, see what we need. We need the sum of this column right here. See that? That's what we need. That's what this little symbol means. It means sum this. All right. And so the sum of x minus x bar squared. So if we sum that column, we get 700. All right. And we know that n is equal to 7. That's how many data values we have. So now let's plug all this in. So I get s is the square root sum x minus x bar squared over n minus 1. And you know something? This up here, I actually put that in there wrong. That should be over 4 minus 1. Sorry about that. All right. All right, so now let's just plug this in. So I get S is equal to the square root of 700. See, that's the sum of x minus x bar squared divided by 7 minus 1. So that is just the square root of 700 over 6. And then if we punch that into our calculator, we get 10.8. And there's your answer. So that's your standard deviation. All right. All right, so what do we have here? So, we're finding standard deviation and everything, but what does it mean? What are we finding? How do we interpret this? All right. So this is not necessarily a problem to calculate standard deviation or anything. It's just kind of it gives you the results and then it tells you to interpret it. It says 2 fifth grade classes have nearly identical mean scores on an aptitude test. So they've got 2 fifth grade classes. These two classes, they took tests, and the class average in each class, they were identical almost. It might have been 20 and 20.1 in the other one, but real close. But one class has a standard deviation 3 times that of the other class. Okay? So in other words, if one class has a standard deviation of, say, 10, the other one has a standard deviation of 30. Okay? But their means are pretty much the same. But their standard deviations, one is 3 times more than the other. All right. All of the factors being equal, which class is easier to teach and why? Okay. All right. So the class with the smaller standard deviation would be easier to teach because there's less variation among the student aptitudes. Okay. So in other words, the coursework. Okay, so the coursework aimed at the average student. Okay, so you've got you've got average students and you've got above average and below average students. So coursework aimed at average students would be without too much concern that the work will be too easy for some or too difficult for others. But in the class with the greater standard deviation, well, if you're teaching to the average student, the students whose scores are way above the mean will be bored, and the ones that are significantly below the mean would be confused. So what that standard deviation does is, so you've got a mean. So the one with the smaller standard deviation, all the other test scores are going to be closer to this mean, but the class that has the larger standard deviation, like say, in other words, the average is, I don't know, say a 70. Say that's the average in both classes. Well, in this class, you may have data like up here, more data up here in like the 95s, or data down here in the 20s. Whereas in this class, you may have one score up here at 90, and you may have one score down here in the 30s, but most of the other scores are going to be a lot closer to this 70 than the scores in this class. Okay, so the larger the standard deviation, the more spread out the data is. All right. And the smaller the standard deviation, the less spread out it is. And so that's what you're actually finding. All right. So, I mean, it's not a long lesson. It's not difficult. It's the only thing is, okay, you've got to know this formula here. And then of course you got to know how to find the range, which is the highest value minus the smallest value. And like I said, if you're, for standard deviation, if you're in a statistics class, more than likely it's going to be a different formula than what we're using in this class. But the main thing is understand how to read the formula. That goes for any statistics class. And then your teacher, they could just make up a formula that looks like this right here with the sums in it and all that. And if you know how to read those formulas, then you won't have problems working whatever they give you. Here's the formula, find everything you need for the formula, and then just plug it in. Okay. Yeah, but I made a mess up over here, didn't I? But I fixed it. So hopefully you understand everything. I hope you did. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.